Hello everyone, welcome back. Today let us start with elliptic curve cryptosystem. So, to understand elliptic curve system, first we will be starting with what is this elliptic curve over field FP. Before that, let us see some history about it. The use of elliptic curve in cryptography began when Lenstra discovered a factorization algorithm over it. So Lenstra first discover the factorization algorithm over elliptic curve. Then Cobbles and Miller Cobbles and Miller independently proposed the concept of elliptic curve cryptosystem. Concept of ECC, let me call ECC, elliptic curve cryptosystem. Okay. The main advantage of ECC is that it provides the same security level as RSA. It provides the same security level as RSA, okay, and others with smaller key size. So this is the main advantage of this ECC, that is elliptic curve crypto system. So let us start with elliptic curve over field. Say FP. Okay. So let F be a finite field. Let F be a finite field of characteristic not equal to 2 or 3, and let x cube plus ax plus b is equal to 0, where a comma b belongs to F, be a cubic polynomial with no multiple roots. What do you mean by no multiple roots? That is 4a cube plus 27b square is non-zero. 4a cube plus 27b square is non-zero. If it is 0, then it has a repeated root. Okay. So an elliptic curve we denote it as EAB over F is the set of points x comma y belongs to F cross F, satisfying the Weierstrass equation. Weierstrass equation. What is Weierstrass equation? Y square is equal to x cube plus ax plus b. Okay. Together with a single element. Denoted by infinity and call the point at infinity. called the point at infinity. Look at the left hand side. Left hand side is y square, right hand side is x cube plus ax plus b. That means see, left hand side has degree 2 while right hand side has degree 3. This means that horizontal line can intersect the curve in 3 points if all the roots are real, and vertical lines can intersect the curve at most 2 points. If the discriminant is non-zero, that is then then it is called non-singular elliptic curve. Then in that case it has 3 distinct roots. I'll just write here note: if 4aq plus 27b square is non-zero, then the curve is called non-singular elliptic curve. So in this case, this equation x cube plus ax plus b, it has 3 distinct roots, and if it is 0, then it is called singular elliptic curve. If 4aq plus 27b square is 0, then the curve is called singular elliptic curve. Okay. See, if f is a prime field fp, then the equation, if f is the prime field fp, then the equation x cube plus ax plus b is equal to 0 has no multiple roots, if and only if GCD of 4aq plus 27b square comma p is 1. The set of points on the elliptic curve form a abelian group under some binary operation addition, and it is defined as below. The set of points on elliptic curve form an abelian group. Under some binary operation plus as defined below. Okay, so how this addition and addition operation, how it is an abelian group, we'll see that. Okay, assume that 4aq plus 27b square is non-zero modulo b. Okay, and define EPAB as set of all x comma y having y square equal to x cube plus ax plus b modulo p, such that your x and y 0 is less than x comma y is less than p union infinity. That infinity is also included. Then EPAB is an elliptic curve and forms an abelian group under the binary operation as follows. First is, if p is added to minus p, then it will give me infinity. That means infinity is the identity element. Okay, p plus infinity same as infinity plus p, which is p. Infinity is identity element with respect to addition. Second, if p is equal to say x1 comma y1 belongs to our curve EPAB, then minus p is what? It is x1 comma minus y1. That means actually whole curve is symmetric with respect to x-axis. Third is, if suppose I am having one more point, if q is say x2 comma y2, okay, belongs to EPAB, and say this q is not same as minus p, otherwise it will be identity, then p plus q is defined as p plus q, we call it as x3 comma say minus y3. This is our p plus q, and I'll tell you how this x3 and y3 are obtained. Is defined as x3 is equal to lambda square minus x1 minus x2, and y3 is equal to lambda x3 plus y3 is equal to say lambda x3 plus c, but then again I can write my c as y2 minus lambda x2. Yeah, we'll fill that gap. I'll just keep it blank. We'll derive and get the value of this. I'll just keep it as it is. So this is my x3, suppose this is my y3, and I have written in terms of lambda, correct? So I need the value of lambda. So what is the lambda actually? Lambda depends on two value. So lambda is, if the points are distinct, then it is y2 minus y1 upon x2 minus x1 if the points are distinct, that is x1 y1 is not equal to x2 y2, correct? And it is this guy 3x1 square plus e divided by 2y1 if the points are same. Okay, so if the points are same, then we are getting this. This is what lambda is. Yeah, okay. Let me write it as y3 will be lambda x3 plus some c, where c is the yeah, you can write y1 minus lambda x1. So this is what your c is. I am having lambda, I am having c. So with the help of lambda and c, I can get this x3 and y3. Okay. And if you put it in here, we'll get the elliptic curve. Now the question is how these are uh, how we got this thing, correct? So let us see geometrical explanation of addition operation. How does this addition operation, how do we arrive at this point? Okay, suppose we want to add, let me just write geometrical explanation. Suppose we want to add points. Points say P, which is x1 y1, and say Q, which is x2 y2. Okay, on the elliptic curve, they are on the elliptic curve. Let L be the line connecting P and Q. Let L be the line connecting P and Q. So if I try to draw here, it is something like this. So it is something symmetrical to x-axis, something like this. The graph is, suppose I am having point, say P is here and say Q is here. This is P. This is point P, this is point Q. Okay, so what I have to do, I have to draw a straight line passing through these 2 points. I hope it goes proper. Suppose this is the line which we are drawing. Okay, this is called line L. Yeah. And it will be a tangent line if P and Q are same. It will be a tangent if P is equal to Q. Okay, that is obvious. Yeah. Let R be the third point. Let R be the third point. Third point of intersection of L with EAB. So if L dash is the line connecting R and infinity, connecting R and infinity, then P plus Q is equal to R dash. then P plus Q is equal to R dash is the point such that L dash intersects EPAB at R and P plus Q, which is your R dash. Or in short, you can say that is P plus Q is the symmetric image of R. Symmetric image of R. Now let me just quickly tell you here. See, this is my point P, this is my point Q. What I did, I have drawn a straight line passing through these 2 points. So this is my curve EPAB. This straight line cuts it here also. So this point we call it as R. Okay. So now what they are saying, try to draw a straight line which is parallel to y-axis. If you draw a straight line which is parallel to y-axis like this, so we will get one more point which we call it as R dash, which is P plus Q. This point is P plus Q we are having. Correct. So that is the basic idea. This is what I have written. So let R be the third point intersection of L and EAB. So this is R, and if L dash is the line connecting, so this is the line L dash. So I am drawing a line L dash, the line connecting R to infinity. What is infinity? Infinity is on the top. You can see on the top I am having this infinity. Then P plus Q is equal to R dash is the point such that L dash intersects EPAB at R and R dash. That is P plus Q is the symmetric image. So this is R. Take the image here. You are getting R dash. This is what the value P plus Q. I wanted to add P and Q. I got here. This is the P plus Q what I am having. This is my P. This is my Q. This is my P plus Q. Okay. Now let us try to do the mathematical computation. Suppose I am having point P, I am having point Q. Can I find the point R? See, point R is intersection of this line and the curve. So first I have to find the equation of this line, straight line L, correct? And then I can find the point R. So let us see. Line L to find. First let us find line L. Line L is actually intersection of 2 points. So let me call that y equal to lambda x plus c. Suppose this is what the line is, where lambda is the slope, or you can call it as tangent. Yeah, it is slope, and that is c is your y-intercept. So c can be easily computed because see, x1 y1 also belongs to the same line, correct? So x1 y1 satisfied, so I can get y1 equal to lambda x1 plus c1. So I can get the value of sorry, it's not c1, it's just c. So I can get the value of c, that is y1 minus lambda x1. So I got the value of c. It was so easy. Now if I'm having distinct point, then how can I get the lambda? Lambda will be just slope. Suppose, how do you find the slope of 2 points? It is y2 minus y1 upon x2 minus x1, correct? If the points are distinct, x1 y1 is not equal to x2 y2. Okay. Now if I am having x1 y1 is same as x2 y2, in that case I am having tangent. And how do you find the slope of tangent. Slope of tangent is just taking the derivative. So what is my equation? Let me just quickly write my equation. My equation was y square equal to x square plus ax plus b. So if I differentiate it, I'll get 2y dy by dx is equal to 2x plus a. So my dy by dx is what? 2x plus a upon 2y. Correct? This is what I'm having. Actually, this is x cube, I'm sorry. So it will be 3x square. Yes, it is 3x square plus a upon 2y. Correct? And at point say x1, y1 satisfy this because they are same. So in that case, my lambda is what? Lambda will be 3x1 square plus a upon 2y1. Correct? So this is the idea. So we got this straight line y equal to lambda x plus c. That means we got our point x3 y3, and that's it. If I got my point x3 y3, how can I get the value of p plus q? I will just write x3 comma minus y3. This is what I had written here. Our p plus q will be x3 comma minus y3, where x3 is this. Now how see we got the straight line. We have not got the value of x38 or y38. We just got the straight line. Correct? Now this line we have found. Now to find the point r, we have to take the intersection of the curve and the line. Okay, so let me write to find r. To find r, see, r is intersection of line L and EPAB. Okay, so it is very simple. You just have to substitute what is EPAB. Actually, EPAB is y square equal to x cube plus ax plus b. And what is your curve? I got my curve y equal to lambda x plus c. Line y equal to lambda x plus c. So if we substitute it here, we'll be having lambda x plus c the whole square is equal to x cube plus ax plus b. Okay. Now we already know the solution. X1 and x2 are the solution. See, everything is in terms of x, and so I can write it as x cube plus ax plus b minus lambda x plus c the whole square equal to 0. So this equation, we already know two solutions. X1 and x2 are two solutions. So we can find third solution by comparing two sides. We can find third solution just by third solution is or simply you can write it as x cube plus ax plus b minus lambda x plus c the whole square is equal to, can I write it as x minus x1, x minus x2, x minus x3. So let us compare coefficient of x square. So what is the coefficient of x square? Here it will be x1 plus x2 plus x3, and here it will be minus lambda square. So coefficient of x square, I'm having minus lambda square is equal to x1 plus x2 plus x3. I wanted x3. So what is my x3? X3 is x1. Oh, sorry, it won't be. It'll be minus lambda square. No, here also minus sign will be there. So minus minus will get cancelled. I'll be having lambda square. So x3 is what? Lambda square minus lambda square minus x1 minus x2. This is what x3. I got the value of x3, and now we know that y equal to lambda x plus c satisfy the point x3 y3. So I can get y3 is equal to lambda x3 plus c, and we know the value of c. C can be written in terms of x1. What is c? See, y1 equal to lambda x1 plus c. So c equal to y1 minus lambda x1. I'll substitute it here. So I can get y3 is equal to lambda x3 plus y1 minus lambda x1. So that can be written as lambda x3 minus x1 plus y1. This is what I'm having, correct? So this is the value of x3. So at last your p plus q will be x3 comma minus y3. What is the value of, write it here. So I got the value of x3 as lambda square minus x1 minus x2, and y3 I got it as y1 plus lambda x3 minus x1, correct? So what is my p plus q? P plus q is, which I call it as r dash, it is x3 comma minus y3, which can be written as lambda square minus x1 minus x2, comma, if I put minus, it will become lambda x1 minus x3 minus y1. This is what I'm having. Okay, so that's all. Thank you so much. We'll continue in the next class.